thanks for inviting me to talk about something I've loved doing since the time I read William Sheehan's book, The Planet Mars, A History of Observation and Discovery. That inspired me to think about the canals of Mars and what caused them. And I didn't even know till years later that Sheehan had solved the mystery by consulting with ophthalmologists who found that Percival Lowell, with his hypertension, had enlarged blood vessels in his eye. And those he was drawing over the smeary surface features of Mars. So I'm going to start with defining what I mean by a VR object, which is what I've been specializing in since 2007. A virtual reality object is something I'm disappointed to learn that I haven't been able to get any major publishers excited about. I'm very excited about it, but Sky and Telescope, Astronomy, Discover, and Scientific American evidently didn't see the power of it. So instead of submitting articles to them, I ended up writing my own book. Sometimes you just have to do it yourself. So you've probably seen virtual reality objects already if you've been car shopping. Here's some, excuse me, here's examples of, if you go car shopping and turn a 3D model of a car all the way around, it's rather crude, it's spaced apart in high intervals, angles, but you can get an idea of what an object looks like looking all the way around. Can everybody still see this okay? Just shout if you can.
Looks good.
So here's how you do it. You get yourself what I grew up learning was a lazy Susan. This one is from 1780, mahogany dumbwaiter, another name for it. And you don't have to pay $3,900 for a lazy Susan. They're a lot cheaper than that. So I'm going to use one right now and show you how to make a virtual reality model. I'm going to start with a small object, a model of Mars. See the polar cap? See Syrtis Major? So you get yourself a lazy Susan, and you put this thing in the middle, and you pick an interval angle. I think the minimum to make it smooth enough is going to be about 12 times 12 around, 12 into 360, about 30 degrees. And then you want to get your smartphone or camera and start low, spin the thing around, go higher, higher, higher. You can do this with a small object. You can do this with a large object. And so the idea is to grab images in slices all the way around as the object rotates. You want to take 12 at even intervals. You can move the object instead of the camera, which you can on a tripod or your phone, and then 30 degrees, 30 degrees, 30 degrees down here. Same thing here, same thing at the equator, same thing higher yet, to get individual images of the whole object all the way around. And then you use a special program to assemble those and display them in sequence using JavaScript, XML, HTML. And there are several programs that do that. And that's essentially how you make a VR object manually. But I do it in a 3D animation program. So back to here. I'll be going back and forth, so bear with me. Oh, right. So how do you make one? Let me show you how before I show you what I did with the program to make these. And my philosophy was going from simpler objects that merely spin to ones that you can zoom in, to ones that have a hyperlinked text, to ones that have a hyperlinked audio, to ones that have hyperlinked simple video, and to ones that have complex video hyperlinked to the model. This is all possible to do. But to make a VR object, I use a program called Blender. And this is a 3D modeling and animation program that is free, open source, developed for free by programmers all over the world. And it is as powerful as other 3D programs like, for example, 3D Studio Max, which I've used for decades. 3D Studio Max costs $3,000. Blender is free, so you can see what I prefer to learn and use now. What we're looking at are, on the right, a camera view, on the left, an overhead view of a sphere made from many, many points, vertices. I set a key over about 500 frames to turn, you can see this on the lower left, the Z direction, turn the object counterclockwise, the way a planet rotates, seen from above, except in the case of Venus and Uranus. Right, so we set a key for the planet to rotate several times over the number of slices that I'm going to do. And in this case, you can actually see the slices for something called an empty object, which is simply, seen from the side, a box that surrounds the object and carries the camera, this wedge-shaped image, this wedge-shaped object on the left, carries the camera with it. So I can tilt and then tilt again, 10 degrees higher, 10 degrees higher, 10 degrees higher, and now I'm at the equator. So I do this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 degrees, 360, that would be, if I use a 10-degree interval, that'd be 36. 36 times 10, that would be 360 separate images. I'm using more in this example. So I'm keying two things. I'm keying the object to spin as many times as my camera tilts, which you could do manually the way I showed you just a few moments ago. I then render the sphere as smooth with a map on it to give it some texture. And in this case, this is a map of an object we'll see later, an imaginary planet, which is not displaying correctly right now. So I'm going to cancel out of this. That's basically it. The 3D animation program, by the way, did take years for me to become proficient at. So there is a steep learning curve, but it is very rewarding. If you'd like to learn more about it, you can give me a call. I'll be happy to give you free tutorials, many of which you'll find on, you guessed it, the master encyclopedic reference that we all use to learn things, YouTube. That's how I taught myself Blender on YouTube. So, whoops. So let's start with Saturn. This is a new VR object. Let's see what a VR planet actually looks like. And I'm going to share, I have several screens to share, so bear with me, my browser. This is an image of Saturn drawn by astronomer and space artist Lucien Rideau, the first scientific space artist from the 19th century. Wow, 2 centuries ago, because we're talking about 21 now. I took an image of Lucien Rideau's and mapped it onto a sphere and a flat plate, a circular plate for the rings, so that I could do this. Moving between dimensions, dragging with fingers or a pointing device. And I could also, if there were more detail in the object, I could zoom in this case by a factor of 2. So a VR object lets you spin around the object. It lets us see Lucien Rideau's image from angles that were impossible in the 19th century, as if we were in a spacecraft. Note the reflected light on the dark side of Saturn. Where is that coming from? Don't all answer at once. The light source
Galaxy.
Coming from the rings.
The rings, correct. The rings. Since they're further away from the globe, they catch sunlight, the day side of Saturn, reflected onto the night side. So that was one that I just completed this morning, about 1 o'clock in the morning, just for you guys, specially created VR object. But it doesn't do much besides that. I mean, there are controls to zoom in and out if you leave it within the browser without going full screen, which is what we saw a moment ago. Lucien Rideau also drew Mars in 1911 with hints the first time of craters. He was the first to do so. And notice if we zoom in, these scalloped features everywhere, little dots, little circles, little scallops. He, decades before craters were photographed on Mars, he had hints of them. He didn't identify them as craters. But clearly the man was a very gifted artist as well as astronomer. He was the first to draw the mountains of the moon correctly as having very little relief, unlike the more famous artist Chesley Bonestell, who illustrated movies from the 50s, Destination Moon, I believe was one, The Conquest of Space. There was a movie that he illustrated for going to Mars. But in those films and in his illustrations, the peaks of the moon's mountains were jagged. Lucien Rideau knew that they were not because he observed the limb of the moon where he could see the mountains in relief. Smart man. He also drew the spokes and the rings of Saturn decades before they were photographed by the Voyager space probes. And so you can actually see what some of the features of Mars in 1911 looked like from a perspective impossible, not from Earth. This one has disappeared in the century since these were drawn. And this area used to be called Syrtis Minor, but dust storms and dust have covered the basaltic rocks in the century intervening. And yet a lot of these features, including this bright one, are still visible today. Amazing artist. In the book, A Traveler's Guide to Mars, William Hartman, actually, I got an autographed copy of this book, and inspired me to ask, well, what caused Lowell to see canals? I did not know that William Sheehan had already solved this years before. This was 2005, approximately 2005 that I obtained the book. But in it is an illustration by William Hartman of what Mars might have looked like if Percival Lowell were correct and the canals were real. So I turned this into a virtual reality object. You can note what happens when you project an image designed to be seen from the front, and it becomes distorted at the limbs. Due to foreshortening of the features, they will be stretched out when we see them face on. This philosophy was used, this approach was used by Gerard Kuiper in the 1960s to look at the North Pole region of Jupiter. He actually took slides, high resolution slides. The highest resolution was 1/4 second of arc, considered very poor nowadays, but that was the best that giant observatories could do in the 60s. Put it on slide film, projected it on custom-made oblate spheroids with the same flattening as Jupiter, and looked at the North Polar regions and noticed intricate patterns that we now see in much greater detail today due to the Galileo space probe or the current probes. So that is a virtual reality model of a Lowellian Mars. Mercury in 3D, some of these features, this one, Caloris Basin, were seen as early as the early part of the 20th century by both Lucien Rideau and Eugene Antoniadi, a French astronomer from Greece. They had a different name for it, but they actually drew it correctly. Looks a lot like the moon, doesn't it? I created an 8K resolution model of the moon with all of the Apollo landing sites. Where's 13? Correct, there is none. They never made it. But we could explore one of them, Apollo 11, in more detail. Because it's a 4K model, 4K means 2160 pixels in the vertical dimension. There's a lot of detail in this moon model. There is a virtual moon that you can explore on your own. It goes almost to the point you can see the objects that have landed on the moon dimly. Oh, you may be losing me. My internet connection has just notified me it's unstable. So do let me know if you lose me at any point. And again, let's try that again for Apollo 12. So tremendous detail in the images that are available free. I got all these images free on the internet. It's like having the world's library at your fingertips. Unbelievable. Pluto and Charon together, so we can see the relationship of their orbits. Pluto by itself. I had the idea that since it's possible to put hyperlinks on these models, maybe I should link something to it. So if we look at these incredible frozen features, this is water as hard as granite forming mountains on Pluto. Click the area and up comes an audio narrated by my wife about what we're looking at. Now, I don't know if I properly shared audio. You can do this at the beginning of your connection with Zoom, but I never received the option. So if you can't hear anything, let me know and I will discontinue playing audio.
Later has some very rough terrain and a clutch of mountains rising up to 11,000 feet or 3.5 kilometers. John Spencer of the Southwest Research Institute says that's far too tall to be big piles of the frozen nitrogen and methane that dominate Pluto's spectrum. Instead, the underlying rock must be stiffer, sturdier, water ice with the hardness of granite.
Don't know
we can hear it fine. Yes,
oh, very
we can.
good. Excellent, excellent. So I also did Charon, the largest of Pluto's 5 moons. So you notice the probe that passed, New Horizons, caught much more detail on one side than the other, and there's a lot of missing information. Someday, perhaps, we'll send another probe past the dwarf planets, including Pluto. So I figured, well, we can go further than that. Why just have audio? Why not, on this model of Jupiter, upon which I pasted artwork by space artist Lucy West, why not also have a little video? And that's what you see right there in the red hotspot. Note the painting, the square. Watch carefully. Take a look at the detail. This is a 4K model, and there's her signature on the painting, painted in 2016. Incredible detail. She paints by hand in the tradition of many artists like Chesley Bonistow and Lucien Rideau, Don Davis, Don Dixon, David Hardy, and so forth. I superimpose that over Hubble data. And all the way around, this complex model yet with 1,296 individual images displayed in sequence by script. So you get the illusion, you see you have a 3D object if you move it quickly enough. If you use a cruder number, a smaller number of images, you must move the model more quickly to get the feel of 3D. I found a good balance with a maximum of about 1,020 images taken 8 degrees apart, 45 all the way around the equator. So what if I click this hyperlink? What will I see?
The entire area within this distorted square is actually artwork. It was hand-painted by space artist Lucy West, who is a member of the International Association of Astronomical Artists. Compare the painting's details with the real image of Jupiter's clouds recorded by the Hubble Space Telescope.
And then again, she painted the polar region of Jupiter that I mentioned earlier, studied by Gerard Kuiper in
The distorted
2018.
bluish square at Jupiter's North Pole is actually artwork. It was hand-painted by space artist Lucy West. Compare the painting's details with the nearby real ones recorded by the Hubble Space Telescope.
And let's zoom in to appreciate the level of detail. Painted in 2018 by hand. Jupiter's polar regions are a maelstrom of swirlies, to use the scientific term. It's actually cyclones. But I just find the Hubble imagery is just so detailed. It's really incredible. Oh, by the way, amateur astronomers like Christopher Go, who use sophisticated equipment to take wonderful CCD images of Jupiter, call this a raft, R-A-F-T. I like the scientific terms that astronomers come up with, rafts.
Lonny, just a question. In that polar view of Jupiter, are any of those from the Juno craft, or is that all Hubble?
This would be, I believe she based this on Juno.
Yeah, it must be, because I don't think Hubble could resolve that kind of detail.
No, not at all. This is all fairly recent. I guess Juno's been there for quite some time.
Yep. Yeah.
Amazing. Who would have guessed? I mean,
Yeah.
you can see some of that, some of those kinds of cyclonic features on Hubble, but there were much better images coming from Juno.
Juno, right.
I thought it was Jupiter was supposed to have a hexagon shape on the pole.
You are thinking of Saturn.
Saturn. Okay.
All right. Taking this a step further, I figured, well, it's possible to do more sophisticated video. So let's take Mercury. I actually found labels on a messenger probe map that somebody had done. So I removed all the data except for the labels, stuck it on a much more recent image, a false color image of Mercury. And let's take a look at the Caloris basin.
Compare maps made by astronomers Rudeau and Antoniadi with images from the Messenger spacecraft. Can you identify any real features? In these inverted views, south is up. The Messenger image has been degraded to simulate the resolution of Rudeau's telescope. The light and dark areas on the right limb were first compared with an Arabic numeral 5 by Schiaparelli, an earlier observer. They surround a feature labeled Pentas by Antoniadi. We now recognize that this is Caloris, one of the largest impact basins in the solar system.
So my wife narrated there. Sad to say, I have yet to pay her for any of the narration she's done. But we can take a look at various features. I've done this for only 4 features on Mercury. One of the most interesting is the antipodal point, the opposite point of Mercury to Caloris. It's believed that the impact that created Caloris also did something very strange. If I can find it, where is it? On the opposite side, there. This is what happened. Oh yeah, there it is. You'll never guess what they call this chaotic terrain. Let's zoom in a bit for some detail.
The impacting body that formed Caloris Planitia is estimated to have been at least 100 kilometers or 62 miles in diameter. At the exact antipode or opposite side of Mercury is a large area of hilly, groove terrain with few small impact craters. It is known as chaotic terrain or weird terrain. It's thought to have been created as seismic waves or ejected matter from the impact converged on the opposite side of the planet.
So, all right, it's possible to do a more sophisticated video. And that's what I did for the latest project on Mars. But I thought it'd be interesting to compare early versions of Mars, but drawn by the early observers with the modern view like this. So you can open virtual reality objects in different browsers and compare them side by side. Note Lowell's drawing style. I found it very amusing as to what Carl Sagan once said about that. Let me show you. Whoops. Uh-oh, sorry, malfunction. Yeah, in making a decision to sell something that I could create, I happened to find that a lot of people beat me to a 3D model of Mars. There was no point in my selling a model that model makers could use to make animations. So I thought instead, I want to do something different. And so that's why I thought to sell a virtual reality model of the planet Mars. And here's my competition, something that works with only iPads. And this is a physical model that's sold with the ability to use alternate reality, AR, to look at hundreds of features and get information about them. There's a problem though. When you look at features of Mars that are illustrated, that are illuminated by light from the sun, the way we usually see Mars, there's a problem. The illumination source is coming from behind us. And so features are poorly illuminated for relief. It's very hard to see relief on Mars. And so this is what a sample looks like of Valles Marineris. When I first heard this term back in 64, I thought, 1964, that is, yeah, I'm a dinosaur. I thought, oh, the marinated valley, Valles Marineris. I wanted to do something different. And so I wanted to include not only some of the principal features of Mars on my model, but every single landing site from 1971 through 2023, which hasn't happened yet. And when I first started making virtual reality planets, I did not have this wonderful new resource. Everybody check out Planetary Mapping, the Digital Museum of Planetary Mapping, .lt.hu. But if you can just search on it, you can find just about any kind of map, like this one from 1958, drawn by Foucault, who in 1933 actually drew a dashed circle, whoops, around this area, Edom, near the pipe stem on Mars, Sinus Meridiani and Sinus Sabius. And he actually drew, without knowing it, he drew the second largest crater on Mars, Schiaparelli crater. This is what I started with. I actually wrote to Lowell Observatory. They were kind enough to send me a high resolution scan from Lowell's book from 1895 of his drawing of Mars with the latitude indications here, which if you measure them are not evenly spaced. Lowell was not, well, you could not call him a good draftsman. I use these references, William Sheehan's wonderful book, The Planet Mars, William Hartman's wonderful book, Mars, The Mysterious Landscapes, A Traveler's Guide to Mars. Two of the best written books on Mars, and I'm looking forward to the new one mentioned by one of our members here, by William Sheehan. Can't wait. Carl Sagan pointed out, quote unquote, Percival Lowell was unfortunately one of the worst draftsmen who ever sat down at the telescope. And it's true, although he influenced generations of astronomers, including myself. I had to physically go in Photoshop and correct the separations of the latitude lines so that I could go from Lowell's Mercator map to a cylindrical map. A cylindrical map that I could wrap on a cylinder, that is wrap on a sphere with cylindrical projection and come up with this, which I could rotate and compare with other drawings of Mars like Rideau's. Or Schleifer. Lowell had a disciple who followed him even after his death and refined Lowell's maps. You can see the same canals are there, but much more elaborate. If we, for instance, look.
Lonny?
Yes.
I'm just seeing three buttons in front of me. So Lowell, Schleifer, and Mars Global Survey.
Oh, okay, yeah. Let me reshare. That's a little tricky. How's that?
Okay.
Okay.
All right, so what I've done is I've rotated the globe of Mars to look at the Nix Olympica area like that, near where all the volcanoes are. If I do that on a modern view of Mars, I would notice something interesting. Note this shape here. Can you see my cursor?
Mhm.
Yep.
And note, similar shape here, kind of a delta. Let's look at Lowell's version.
Hmm.
Huh? Yeah, completely missing. Well, so they did get albedo features correct. Careful observers of Mars did correctly map albedo features. It's unfortunate they didn't know what they were looking at. And part of the problem is, well, it's sixfold. There's 6 reasons why they barely missed seeing what spacecraft saw. One of the best observers of Mars, even one of the best, Antoniadi, only drew a bright patch in the area. They were seeing clouds on the flanks of the volcano, Olympus Mons. They called it Nix Olympica, which was very prescient of them to include the word Olympica, home of the gods. And we've already seen Rideau's drawing of Mars. So let's conclude by looking at the VR Mars, the latest. I explained why early observers just barely missed understanding what they were looking at on Mars, but a big reason, one of the principal reasons, is the way Earth and Mars align and the fact that Mars is small. Look at the Terminator in these wonderful shots by Damian Peach. Damian Peach is a premier photographer. Well, do we say photographer anymore?
Imager.
No, we don't. What's a photograph? What's film? The Terminator of Mars is never very far from the limb when seen from Earth, because in order to see Mars, an outer planet, we have to wait till we line up. The sun is behind us. The illumination source makes it very difficult to see features at the limb. If only we could see the relief, we would have understood early on that Mars is cratered. And this is why I made my Mars VR model illuminated from the side. That's the best way to see relief on Mars, and it's more accurate and less fanciful. So as an example, take a look at volcano Alba Mons in the north and east of the famous volcano Olympus Mons, the ones most of us have heard about, one of the tallest mountainous volcanoes in the solar system, if not the tallest. Alba Mons lies in this direction. It's actually larger, but flatter. And so as it approaches the limb, watch what happens. Relief, previous, next. All right, as it gets closer to the limb, it's much easier to see the relief. Principal reason for my choosing this kind of a view of the Mars VR, which I'm going to market later this year if I can get the technology straightened out. There's several different things that need to be done. I am currently constructing a website and then an app, and then try to link that to DigitalOcean. It's a complex project. So let's stop sharing here and take a look at the Mars VR project itself. Whoops. Let's see. Right? Questions while I bring this up?
Sure.
Well, I have a comment to make, Lonny. I've been a fan of the history of Mars as well, like so many of us have. And what's particularly illuminating to me is to see how accurate an observer and keen-eyed observer Antoniadi was, because that he could resolve detail on Mercury, the positional detail with such accuracy is stunning. I did not know that.
Yeah, dealing with resolution of only a half a second of arc,
Right.
the usual limit of the atmosphere, it was amazing he saw anything at all because Mercury is so tiny. What they
Right.
didn't do, and what I explain in my book, is wait longer than 7 years to see new features rotating into view
Right.
because of Mercury's weird resonance with
Right.
Earth and the sun.
Right.
You know, three rotations for every 2 revolutions.
Right. Well, they didn't know that, of course. There was all kinds of debate as to what the actual rotation rate was.
Right.
And people, even as late as the 1960s, Clark Chapman actually observed Mercury visually, and he came up with a different rotational rate, which was actually fairly close to the actual one. But then he was cheating. He was on his way to become a modern astronomer. Also, FYI, William Hartman is one of the contributors to the book I was telling you about. He's quite a gifted artist in his own right, not just astronomical art, but other art as well.
Right, but I actually used him as a reference in my book.
Right.
Conversation by email. His book inspired the whole idea of doing virtual reality planets.
Yeah. He also has a great sense of humor.
Yeah, I hope to see him. I hope to see all the space artists. Most of them live out west. Once again, if I can travel.
Yeah.
So here is the interactive Mars VR that I've been working on the past year. It is finally complete and it's almost ready to market. You can zoom in by a factor of about 5 to see tremendous detail, or you could go full screen. You can look at landing sites, and you can see video on Vimeo. You have to enter the password. You can all try this out. The password is discover, all lowercase. And you'll hear the wonderful Jan Buinis narrate the video.
Opportunity, Rover B, or Mars Exploration Rover B, landed in Meridiani, Planum, on January 25, 2004. The mission was active 2004 to 2018. Space historians considered it one of NASA's greatest successes. Opportunity recharged its batteries with solar power and hibernated during dust storms to save power. This helped it exceed its operating plan by more than 14 years. By last contact, the rover had traveled a distance of 45 kilometers, or 28 miles, and held the record for achieving the longest off-world distance. Opportunity found the first meteorite foreign to Mars, named Heat Shield Rock. The rover extensively explored Victoria and Endeavour craters. A planet-wide dust storm in 2018 put an end to activities, and on February 13, 2019, NASA officially declared the Opportunity mission complete.
So that gives you a sampler of the kind of videos that I've done for this. There are 28 in all, and I can add more in the future. They're all designed for the attention spans of Generation Z. If you can't make your point within 5 minutes, you're sunk unless the content is very compelling. All the videos I've made are under 2 minutes. Many of them are under 1 minute, and some are 30 seconds. But there's a host of features to see. Especially, I'm very proud of Noctis Labyrinthus, which uses a custom animation. One of 8 that took, one of them took days, weeks to construct, most of them a day or 2. But here's my last sample before we open for questions. Noctis Labyrinthus, beautiful part of Mariner Valley.
Noctis Labyrinthus is a maze of steep valleys and canyons on the western end of the Great Rift Canyon, Valles Marineris. Because it is central to the Tarsus Rise system of volcanoes, areographers attribute the formation of Noctis Labyrinthus to faulting and compare it with similar sunken structures on Earth called grabunds. This is one of the most diverse sites to find minerals on Mars. with deposits of iron and aluminum-rich minerals and volcanic glass. The edge of this pit depression shows a light tone layer deposit on the upper wall. It's probably jarosite, a potassium and iron hydrous sulfate common on Mars. Jarosite forms only in the presence of acidic water. This layered mesa displays faint bands along the lower left edge. They may be sedimentary deposits exposed as the mesa erodes, similar to those seen in western United States deserts. Temporary hazes and clouds frequently form over this region. This has inspired several space artists to depict beautiful scenes of low-lying fog in Noctis Labyrinthus. Here is artwork by Pat Rawlings. You may find it easy to remember the scientific adjective attributed to this unique formation. Pretty.
Yep, science is fun, isn't it?
Yep.
So all of these images that you see in the videos are free in public domain or free with credit, for the vast majority paid by our tax dollars. NASA. And finally, to conclude, I want to show you two more things that you can do with virtual reality models. Oops. Oh yeah, I forgot to show you a comparison. Oh, share. Here's all of them together.
Oh, yeah.
And you can see how close Verdot and Antoniadi are to modern. Again, the contrast is exaggerated. I actually boosted the contrast on the modern Mars so you could compare it with the maps. Much easier. In fact, in reality, the features on Mars are fairly low contrast. Again, making it difficult to see reality.
Notice how.
Go ahead.
Sorry, I didn't mean to interrupt. Notice how Syrtis Major has changed since Antoniadi drew it.
Yes.
Just phenomenal. If you can stop it there for a sec, can you see Syrtis Major is on the modern one is on the top left there, top bottom right rather there, and then it's here over here by Grudot and Antoniadi. It's quite a different shape and outline.
Yeah.
It really gives you a good idea.
And this this feature here has faded enormously over the century.
Yes, it's gone basically.
I believe they called it Syrtis Minor somewhere around.
Yes, they did.
Wow.
Yeah, quite amazing. So animation is a good way to bring these ideas home.
That's terrific. Very nice.
And finally, to conclude my talk, I just want to show you two more virtual reality models that are explanatory of exoplanets, the new interest. I can't wait to illustrate some exoplanets. This is how the Kepler Space Probe worked to find Earth-like planets. So the tilt must be exactly right, or you'll see nothing. Note the giant planet shadow? We'll miss if the tilt is too high, the vast majority of systems. And then the Earth-like planet right there,
We can't see a planet.
tiny portion of the disk of the star. The light level, you have to be very precise in measuring the drop in the light level as these transits occur.
Lonny, we're just seeing Kepler and
Agrona.
Oh, I'm sorry. Yeah, again, I think it didn't work properly. Let's try that again.
Okay.
There you go.
There we go. So note the eclipse happening with both the terrestrial and the giant planet. Very, very tiny, hard to see the terrestrial planet. That's an Earth-sized planet. That's a Jupiter-sized planet around a sun-like star at 0.01 and 0.04 AU, I believe. I forget my actual figures. But if the tilt is wrong, the vast majority of systems are tilted at all different random angles to the sun compared to us. So we have to catch those few systems that are lined up just right. So this is a good way to illustrate how exoplanet detection works. And then we also have.
If I can interrupt, real quick, Lonnie, that illustrates why there is a natural bias in our discoveries of exoplanets.
Correct.
If the planets are orbiting much closer to that star, you can tilt the plane of that orbit a lot more before it doesn't eclipse.
Right.
And that's one reason we are finding so many solar systems with the planets close to the stars.
Right. That's a bias. But it's an interesting surprise that so many smaller stars have habitable zones. There could be a lot of interesting habitable planets, one of which was invented by a college student who's trying to join the International Association of Astronomical Artists. This is a planet designed by Henry Welch as a graduate project. He's making a website, and so I volunteered to create a virtual Agrona, his planet Agrona, which has tremendous detail. This is a 4K resolution. So you can see the bump mapping is pretty effective.
Why is it so red, Lonnie? Are they all Republicans there?
Yes, this is a wonderful, if you're conservative, you want to go to this planet. The vegetation is red. The creatures live, he's invented a wonderful series of creatures, much like Carl Kofwed and other artists who are famous for inventing aliens, but he's actually doing it scientifically. I believe he's got a minor in exobiology. But yes, all these creatures vote conservative. Yep, so that is pretty much how virtual reality planets work. And I'm going to stop right there and see if we have any questions.
Well, I was just gonna, if I may, comment about the transits of exoplanets. I'm in the process of writing an article on that too. One of the problems with Kepler was that it actually missed, very likely, the opportunities to actually catch Earth-sized planets because it caught mostly big Jupiters, in part, and close-in big Jupiters, in part because, Kepler was really operational in its primary mission for only about 3 years, which means unless you caught a planet that circled the star within 3 years, you wouldn't see it, even if the angle was ideal. And so our sampling actually of Kepler results is pretty much biased towards larger planets and smaller planets.
What I found interesting about that, it was not only a surprise to me when I heard that, but that the more and more accurate simulations that are possible due to supercomputers show that early on in our solar system, Jupiter and Saturn were much closer in. It started out that way and then migrated.
Right.
Yep.
So there's an interesting idea that giant planets can form fairly close.
Yeah, and the other thing too is with modeling now of these types of things that you just mentioned. Did you ever read the book called Rare Earth?
I have a bone to pick with those authors. I have not read it. I've read a lot about it.
Yeah, but the thing is, basically they argue that because our sun is a Goldilocks star, we're in the right habitable zone. We have a moon, we have tectonics, we have all of these things. The Earth is so likely to be unique that advanced civilization and life like we have here on Earth is likely to be very rare. And so they make the whole argument that we may be the first and only one in the galaxy, etc. I don't buy that, but I mean, they can make that argument and they can do it quite effectively.
What they've noticed is that Earth-like environments were not the only place to find intelligent life or advanced life, because they entirely missed life inside the moons of giant planets. In fact, that may be more plentiful than Earth-like planets.
Right, absolutely. And but the other thing too, which is becoming apparent now, I remember a few years ago, there was a young astronomer at Lowell Observatory who was convinced that the best places to look for are white dwarf planets. because first of all, there's so many of them, and it was pretty easy to detect giant Jupiters around them. The problem with that is that most of the planets around dwarf stars end up like the moon, is that you're tidally locked, so they always place the same face in that direction.
That's the other challenge that I want to do. I want to illustrate this or animate such planets to see where the habitable zone will be along
Right,
the terminal.
right. I figured you might be going that way. Yeah, that would be really helpful from what you're trying to do, actually. So I'd suggest you pursue that. That would really be interesting.
Good
Nice
question.
work, very interesting.
Thank you. So I'll be excited to announce later this year, I hope, the sale of the Mars VR model, but you can all try the sampler that I gave a link to, and that's an HD sampler. The full model is 4K, much smoother, more images to smooth it out, and prettier. Also, the HD sampler has only 5 of the videos narrated by my wife, but you can try them out, password discover. And that's because I submitted the idea to a high official at Discover, the company that's responsible for the magazine and the series, and got no response, as usual. I'm not discouraged.
Yeah. I hope, have you patented this process? Can you patent it?
It's copyrighted with the government, our government agency.
Good, good. Yeah, well, copyright only lasts for so long though, but my suggestion would be, if you really are pretty close to getting something commercial, try to file a temporary patent application, which essentially gives you, it's very inexpensive, just a few $100s, and it gives you essentially a year or 2 to file a full patent. And should your, but it's protected for that long. And should you then go commercial, then and start making lots of money, then you can file your proper patent, and it'll be protected for 20 years or something.
Well, I appreciate the advice, but this is probably not something that can be patented because it's not an invention. It uses existing programs, other people's programs and images.
Right. Doesn't matter. It doesn't matter.
It's a clever way of assembling pre-existing elements.
Right, but it doesn't matter. You can use, you would be the first person to use all these other methods in a perfectly novel one.
Well,
okay, so you probably can patent it. And I'll give you an example. The company that makes Advil, right, for years had the patent on that. And then recently you might have noticed that now Advil comes out as a combination of the NSAID and Tylenol, and it's patented for another 20 years. So mind you, they have good lawyers and lots of money. But my point is, you can take 2 very different things, put them together. The idea is not the technology. The idea is that you put them together. That's what you're protecting. I used to do this at my university. Trust me, it's a sneaky trick whereby if you want some protection to see if your idea actually takes off and might make you some money, a temporary filing will protect it for that long.
Yeah, and then if somebody else uses your technology, you know, with better graphics or bigger computers or whatever, they could pay you fees.
That's right. You could license them. Think about it.
All right. I can't patent the idea of a virtual reality object. That's been around a while, but this would be applying it to an educational product.
Exactly.
All right,
so that's the novelty then that you want to go with. So yeah.
Thank you.
And if you want, if you're welcome. It really is, a lot of people don't know this, but you can get at least a year's worth of protection. And then if it doesn't work out, you just let it go. But if it does work out, and then you can license it, you might be possibly then to get at patent, or somebody buys it from you. You make lots of money, and then they file the patent. It's a bit of a shell game, but that's how the big boys do it.
Okay. Question from Lou.
Yeah, Lonnie, thank you for presentation. I missed the first part, and I apologize, but I'm just trying to recall your market. So your audience for the product, is it more of like the mobile device, or are you looking at sort of a larger venue, like from a teaching point? It seems like some of the planetariums that I go to nowadays, don't show stars anymore. They just seem to show a lot of graphics and things like that, which are very interesting. But I could certainly see your spheres and revolution on a large, 2-story, 3-story screen. That would be kind of neat.
Yeah, well, it's designed to be interactive. So if a museum had a large touch panel, really big, like 3 feet across or more, people could come up and manipulate the planets with their hands. This works on every device, Lou, every known device. Touch sensitive, not touch sensitive, computer, laptop, tablet, phablet, phone, you name it. I've tried it on all. You can try it too. You don't need to have, you can use your fingers on a phone, you could use a mouse, joystick, anything. It's designed to be interactive, and that's the fun part. So for kids, for adults, children of all ages, that was the intent, that everybody could use this for edutainment. You can learn about Mars, but you can do it in an entertaining way. You can explore without knowing. You could look at my keys. I've actually made keys like maps, like a National Geographic map with features labeled. You could just click on that to get to the videos. You can look at it and try to find it on the 3D model. You could go mystery meat, just explore on your own to try to find out what it is. When you hover over a hotspot, a little label pops up and tells you what it is. So it's a fun way to learn about exploring the planet. I call it two catchphrases. Hold the planet in your hands, or explore Mars with your fingertips.
I'm just wondering, this is totally off the total base here, but obviously you're aware of what Lowell is doing with the new sort of discovery center. Am I getting the terminology right, Klaus? That's
yes.
And they're
Astronomy Discovery Center.
Astronomy
ADC.
Discovery Center, and they're I don't know the technology that they're looking at. I don't know if it's all locked in place yet or not. No. But obviously the Mars connection would be pretty cool if you had something like this as part of that Discovery Center. I don't know who Lonnie would even approach to.
Well, I could be an intermediary because I'm a member of the Lowell public program. And it's something that I think, Lonnie, if you were to get some of the educators together at Lowell and give you a presentation, as you did tonight, and then I'm sure they would have ideas as to how and where it might be applicable. For example, one thing that the Discovery Center will have, be planetarium and the like, but there'll also be a whole series of stations where different planets or different factors are being dealt with. And you could have a screen where kids could go and play with planets. I mean, and adult kids,
Yeah. Well, I'm so enthused about this, but I don't see a lot of enthusiasm from the professional people I've approached. But do you guys think that I'm on the right track, that this is something to pursue? Because I've been excited about this for years.
Yeah, well, the thing is, Lowell is very receptive to new ideas, especially when it comes to educational and public outreach. And it seems to me that this idea, if you could demonstrate that, maybe even come out for a trip and visit with the folks involved, that's probably a better approach.
I'll be retired starting September 1st and have more time.
Well, so keep that in mind.
Yeah.
They
You
can
always
always
have a
watch.
place to stay, by the way, Lonnie.
Sorry, Barry?
You always have a place to stay if you need it.
I appreciate that. Thanks.
Yeah.
And
you could show this video to Lowell also.
Well, that's what I just said.
Yeah.
I mean, but I think the best thing would be to come here and do it. Because if you're here for a day or so and you can interact and discuss, and they might have other ideas and suggestions. But that might just fit very nicely into the Discovery Center. That's a good idea, Lou.
And I think that, they just broke ground. So they're about, about 18 months or 2 years away before actually having, but now is the time to, get in there to, if they have blank areas in the space
Right.
that, they're looking for content and I know they have sort of this grand scheme of things, but I could see something like this that works seamlessly in some type of progression of planets and stuff, and even the exoplanet angle is pretty cool too.
Yeah.
I mean, and you've done a lot of the heavy lifting as far as stuff. All you need is some type of projecting mechanism. And again, you're looking at 5-year-old kids and 10-year-old kids trying to do this thing. And I think it would be really cool for them. And but now is the time probably to have those discussions with Lowell to see if they have any places for something like this. I have no idea whether the content is already.
They will. No, I mean, content can change easily.
Oh, that's true. I think that's a good part too. So if this thing could change, maybe you're highlighting this planet this month, and
right?
Then next year you highlight this planet, and so it's not the old models which you got to take out and put in a warehouse somewhere. Now you got a model, you just download it, and that's the model du jour.
Right. Yeah, absolutely. And in addition, what I would particularly focus on is the thing you showed us about Mars, those last 6 images, what it looked like, and so on. I think a lot of the, Mars is still the pet planet for Lowell. And also there is now a huge program with the Northern Arizona University where they actually interact with the faculty there. They have just started a doctoral program in planetary sciences, and many of the astronomers and students come back to Lowell and are supervised there. So the idea of having a virtual kind of model that they might be able to use for instruction at the university even, or there's going to be a large exhibit station in this center with beautiful images, everything from galaxies to exoplanets, but particularly still solar system science. So I would get out here if you can and make an appointment to see some of the professionals and educators and give this demonstration and solicit feedback.
Okay.
Yeah.
Good ideas, all.
Yeah.
All right.
Mm-hmm.
The one thing I think you should add, though, when you do the Mars thing, when you zoom in on these fine structures, you should really have a little guy in a gondola, going down one of the canals.
That can be done.
I know it can be done.
Animate anything.
Have little Martians.
Yeah, exactly.
And they don't have to be green.
No, heck no. Well, thanks very much. I'm going to leave the meeting now. I've got some other things to do. Enjoyed your talk very much, and hopefully you can come visit.
Yeah, this has been a great honor. Thanks.
Lonny, stay on for a minute. I want to talk to you.
Sure.
Okay, if this is over, I'll stop the recording.
Okay.
Okay.